you guys click the words turned in, it's nothing to me if I don't actually see the work. Okay, so don't just automatically say, I did it, trust me, turn it in. I need it uploaded, and I'm not sure how you guys upload. Here's what some people did, which I thought was really clever. They uploaded the PDF file. So they went and they took the PDF file from the factoring review, and when they uploaded it, they were able to work on it in DocHub, and they actually just did the factor boxes right on top of the file. So if you go back to the Who Killed, they did the factor boxes right in here and then just sent it back to me. Okay, so whatever works for you, but I do need to actually physically see that. It's not enough to say you did it and check turn in. I actually need to see it. Okay, you guys good?
I'll check on it.
Okay, so let's see, today's was, oh, I opened the wrong one. Graphs. Not see. Oh, here we go. Okay, today we're reviewing graphs. So without further ado, let's get this party started. Okay, so today we're talking about X and Y intercepts, domain and range, evaluate for a given function, increasing and decreasing, max and mins, and behaviors, asymptotes. And we are not following the alternative learning plan. People keep emailing me that. What happened to Sanaya? There she is. People keep asking me, are we following the alternative learning plan, which means they're not watching these videos. They're not bothering to tune in because I've been very clear that we're not following it. We're doing our own thing for now, just because the alternative learning plan makes us go back and redo work that we've already done. Right now, this week, they're doing the sequences and series, which we've completely done. All right. So let's talk about functions that pass the vertical line test. So this one, here's my vertical line. And it never touches the function in two places or more at once. It only touches once or none. So we can say, yeah, that's a function. It passes the test. The line doesn't touch two or more spots. How about this one? Is this a function? Faith is saying no. I saw her shake her head. She's correct. Stephen, how about this one? Is this a function? Yes. Does it pass the vertical line test? Remember, the test says, you weren't here for the semester when I taught this, by the way. The vertical line test says you cannot touch the function in any more than one place as you cross, as you go from left to right. So what is yours? No, because you're touching a lot more than one place. As you go this way, you touch 1, 2, 3, 4, 5 places. All right, so now I'm going to ask you, is yours a function down here in this bottom corner? Yep, it sure is. And then let's do the last one together. Is this one a function, guys? Does it pass? Nope, it does not. Faith is right. I saw her nod her head. Okay, so that's how you tell if it's a function or not. Okay, now for X and Y intercepts. So on the X-axis, you're going to put the number where it crosses the X-axis first in parentheses, -2, and then follow it with a 0. On the Y-axis, you put where it crosses the Y-axis in parentheses, but the 0 for the X has to be first. So that's your X-intercept because Y has a 0 spot. And this is your Y-intercept. So for the Y-intercept, the one goes here. For the X-intercept, it goes here. For this one, you can see that it's, I don't know if you guys can see my screen. Looks like the X-intercept is at -3, and then there's another one here at +1. So I've got a -3, 0, and a +1, 0. And the Y-intercept is at +3. So it should say 0, 3. Remember, where you put the 0 is super important for X and Y intercepts. Now for this one, you can see, make it a little bigger. that all the way from -5 to -2, it's on top of the x-axis. So rather than just list the points -5, -4, -3, and -2, I just said there's an infinite number of x-intercepts between -5 and -2. So all the little spots in between also count. And then you see over here, there's another x-intercept at 3. Okay, and then the only y-intercept is at 4. So it's 0, 4. Okay, here. What is the y-intercept? Let's do the easy one first. What do you guys think? What's your y-intercept? I'm looking for, hang on, let me see if my chat is open. Oh, somebody did chat to me. Yes, Sanaya, thank you. 0, 1. I just saw the chat room. Let me move my chat. Everything is always in the way. Yes, it is. It's 0, 1. What about the x-intercept? What are you guys thinking on this? Try talking, Sanaya. I think I've unmuted you. Say something.
Hello?
I hear you. Yeah,
Oh, okay.
you're good. I think I had forgotten to unmute you when you first came in, but I hear you now.
Okay.
All right, guys, this is the key question of the slide. What is the x-intercept up here?
Uh, 0, 0?
No. What does open bubbles tell us? Is there actually a point there?
Oh, no?
No. So is there an x-intercept?
No?
No. No x-intercept because of the open circle. All right. Moving right along. Domain and range. Remember, the domain is the x value, so I put that across the top. And the range are the y values, so I made that go up and down the side. In a case like this, they go forever to the left and forever to the right with one flat area in between. So we can say that the domain is all reals. And it also goes forever up and forever down. So we can say the range is all reals. Remember when we use function notation, we put it in parentheses with a negative infinity to positive infinity. Do you recall that? Stephen, I know you don't because you weren't in my class at the time. But we did negative to positive infinity.
Mm-hmm.
Stephen, not if you understand what I'm saying. Stephen, okay, I'm not sure what your earbuds are in for. Okay, thank you.
I'm at work, so it's kind of loud here.
Okay, I got you. I wasn't sure if you were listening to music or me, so I'm cool with that. That's okay. You're good. Okay, so if there is an actual point there, we put a bracket instead of a parenthesis. But if there's infinities, you cannot say you ever reach infinity. It's not as one set point in space, so we always put parentheses instead. So for this one, it's going to be the same domain. It goes forever to the left, and then it starts here where there was a bubble, and it goes forever to the right. So we can say the domain is all reals, and the range is also all up and all down, so the range is all reals. But here's where it gets tricky. Now I have a point here, so there's no arrow. It doesn't go continuously this way, and a point here. So again, it doesn't go continuously this way. So my domain starts at -5, travels across the graph, and then there's a break from 1 to 2. Do you notice there's no graph between the 1 and the 2? So here's what we did here. We said it started at the number -5, so you bracket it. And it went to number 1, so we bracket that because there's actually points at those two values of x. But then at the number 2, there's an open circle, so you have to use the parentheses. And then at 5, there's a closed circle, so we get to use a bracket. Do you guys remember that when we did those? That's called function notation, or interval notation, I'm sorry. Anybody remember that? That was way back in, I think, chapter 2. So it's been a while. It's not a hard concept. If there's a closed circle, bracket it. If there's an open circle, parenthesis it, and you always put parentheses on the infinities. You never put a bracket on the infinities. So now let's do the range. You start down here at the number -2. And of course, there's a bracket because it's an actual solid place. And then we go up the graph. I see points all the way up to this value, and there's a circle. But if I travel across, there's actually a point at 1. It may not be here, but it is here. So we can include 1 in the range, and then it continues to go up to the number 4. So we would bracket the 4. So even though there's an open bubble here, the fact that the graph has some other part of it that has the value of y as 1, we can continue on up. But now here, you can see there's a gap. So we start at negative, well, actually, let's go this way. The x-axis goes forever to the left and forever to the right. So we do have all reals, because even though there's an open bubble here, there's a closed bubble above it. So that x value still has a point. Now the range starts down at -infinity. And remember, you never put a bracket on infinities. And it goes up to 0, but it does not include 0. So you also have to have parentheses on the 0. And then it jumps up to 1, and it picks up at 1. And notice it's a bracket because there's a solid. So it goes from 1 all the way up forever to infinity. And we never bracket infinity. We always put parentheses on infinity. Okay, are we good?
Mm-hmm.
Huh? Okay. All right, now this is evaluate a function for a given x value. So remember when we use function notation, we call it f of x? Well, this is saying find f of -3, and that's only asking you for the y value at the point where x is -3. So I'm going to go to the x-axis and look for -3. There it is. And I find the graph at that point. Well, the graph has a point down here for this x value, and I read its y value of -1. Everybody catch that? Okay, good, because there's 3 of these left. I'm going to do this one, and each of you is going to do one of these. So for -2, I have to find -2 on the x-axis. And I read the point for the graph. What is its y value? Well, the point is right here on the x value axis, so it's a 0y. Now I'm going to find f of 0. I find 0 on the x-axis, and the graph is up here for that x value, and the y value is 1. And now I'm going to find f of 1. Here's 1 on the x-axis, so the graph is up here. It also has a y value of 1. And f of 2. Here's 2 on the x-axis. I go up to the graph, and it has a y value of 4. All right, don't all jump at once. Who wants to do the next one?
I'll do it.
All right, go ahead. F of,
0.
go ahead, I'm listening. I hear you typing, Sanaya. I can actually hear you.
Really?
I can hear you. The other 2 have muted, so go ahead. This one's yours. I'm going to unmute them for one of the next 2. What is f of -3?
0.
Correct. What is f of -1?
2.
Correct. What is f of 0?
3.
Correct. And what is f of 1? Here you've got 2 choices, either this one or this one. What are you going to go with?
0.
0 is correct. Well done, you. All right, who's going to do the next one? Okay, Faith, you have to unmute for me because I'm trying to unmute. Okay, good. I can hear you now. What is f of -5?
Would it be -2?
Okay, if you're here on the x-axis, you have to go back and read the y-axis. What's the y-axis? Yes. And what is f of -2?
0.
Correct. And what is f of -1?
Being 3.
Correct. How about f of 0?
4.
Correct. How about f of 1?
3.
Correct. And what about f of 2?
0.
Okay, so this one has the only place on the graph you have an x value of 2 has an open bubble. So what does that tell us if there's an open bubble? Is there actually a point there?
No.
No. So would you have a y value?
No.
No, undefined. Good. All right, Stephen, you're up. You have to unmute yourself because I'm trying to and it won't let me. Or you can type in the chat room, Stephen, but either way, you get to do this one. Your boss is talking. Your boss is talking to you in the middle of a... What is your boss saying to you that's so important it can't wait? Are you on some kind of a conference call with work? Okay, type then. I'm watching you chat. All right, what is f of -1? All you need to do is type a number in here for me, Stephen. Here's -1. What is f? Do you even know what we're doing here? Okay, we're reading the y value. So if the x value is -1, you find the point on the graph and read its y value. The y value for this is also -1. So if f is 0, if x is 0, you have to read the y value. Well, this point doesn't count, but this one does. There you go. If f is 1, if x is 1, I keep saying f, if x is 1, what is the y value for that point? No, try it again. X is 1, go up and read the y value. There you go. And now if x is 2, go up and find the y value for 2. Sure, good. All right. Way to multitask. Impressive. Okay. So now we're doing intervals of increase and decrease. So I'm going to do the first one, and then there's 3 more. Okay. So the blue part goes from -infinity to -1. And because you always read a graph as you go from the left to the right, I can see it's increasing. So I would put that part under the increasing. The red part goes from x of -1 to x of +1. And it's just flat. It doesn't go up or down. So we call that a constant. And then the green part goes from an x of 1 all the way out to an x of infinity. And you can see it's still rising. So I'm going to put that under the increasing. So for this graph, it increases on these 2 intervals, green and blue, and it stays constant on the red interval. Everybody understand that?
Mm-hmm.
Okay. Who wants to take the next one? There's 2 pieces, a -infinity to 1 and a 1 to infinity.
I'll try.
Okay, go on, you're up. Where should I put the -infinity to 1, the red piece?
Increasing.
Correct. And where should I put the blue piece, the 1 to infinity on the x-axis?
Constant.
Say what?
Wait.
As you go from the left to the right, what does the graph do?
Increasing.
Correct, it increases, right. So notice that these values inside the parentheses are for the x values on that interval. We never read the high-low values. We only read what it's doing across the x-axis. Okay, so yours was good. Okay, it's either Faith or Stephen who's going to do number 3. Who wants it? Okay, Faith, you're up. I think you have to unmute for me because I think you keep muting back. Okay, so let's start with the red piece. From -5 to -2, what does your graph do?
Increase.
Watch what happens. You're going from left to right.
-5 to -2.
Yeah. Does it go up?
Oh, wait, no, it's a constant.
It's constant, you're right. It actually stays flat, so that's a constant. Okay, so now from the next piece, it goes from -2 to 0 on the x-axis. What is your graph doing as you ride from -2 to 0? Just follow your eyes. Where do your eyes go? Up, down, or straight across? I hear you. Why are you typing?
Because I couldn't hear you.
Oh, you can't? Can you hear me now?
I can hear you now, yeah.
Oh, okay. So from -2 to 0 on the x-axis, look what your graph is doing. What do you think?
Increasing?
Correct. Okay, but then the blue graph suddenly does this from 0 to 1 on the x-axis. Now what's it doing?
Decreasing?
Correct. And then from 2 to +5, what is it doing here?
Increasing?
Well, look as you go this way, what are your eyes doing? Are they going up, down, or staying across?
Oh, there, it's a constant. Right?
Not quite, because a constant would be like this. The flat lines are constants. So this was a constant and this was a constant. But what is yours doing from here to here?
Oh, it's decreasing.
It's decreasing, right? Good. So yours has many parts. All right, Steven. Can you just type for me? What does
I'm
the,
good now. She left.
okay, thank you. What does the red piece do? Remember, you're riding
Decreasing.
across the graph from -infinity to 0. What are you doing?
Wouldn't it be decreasing?
What are you saying to me?
Wouldn't it be decreasing?
No, because what you're doing is going from this backwards. You have to start from the left side of the graph and go forward.
Oh, so it'd be increasing.
Yeah, that's right. Because from the left to the right side, you're actually traveling up. And then what does the blue piece do as you go this way? What froze? Did I freeze?
Oh,
Are
there
we
we go.
back?
It
Okay.
froze there for a second.
Yeah,
we're
somebody's
back.
internet.
Yeah, my internet here sucks, but I gotta deal with it.
So what does your blue
Um,
piece do?
Wouldn't it be increasing too?
Yeah, that's exactly right. It increases too. Well done, guys. Well done. All right. Remember that you always call out the x values for increase and decrease. You only look on the x-axis and say, well, as this green piece goes from here to here, I go from 1 to infinity and I'm rising. As this green piece goes from here to here, I go from 2 to 5 and I'm falling or decreasing. All right. Max and mins are pretty easy. The maximum of a graph is the highest y value and the minimum is the lowest y value. So tell me what you think the highest y value of this graph is. Read the y-axis for max and mins.
4.
4 is correct. And what do you think the lowest value is?
-2.
-2 is correct. That's it. Max and mins are pretty easy. All right. And then for end behavior, I know this is going to throw you off a little bit because this one was a little bit more difficult than most. For end behavior, we say, where do the y values go? So if I'm looking at the left side of the graph, they go down. And down is just another way of saying negative infinity. And if I'm looking at the y values for the right side of the graph, they go up. And that's another way of saying positive infinity. And when I say y values, they call them f of x sometimes. You know f of x stands for y, right?
Mhm.
Okay, so for this one, it goes up and up. So we would say, as x is going negative, it's going this way, y values are going positive, they're going this way. But also, as x values are going positive, x is going to positive infinity, y is also going to positive infinity, or we say f of x. So remember the arrow means approaches. They actually mean x approaches or y approaches. Okay, and then this one, you can see that the y's are going positive infinity as x goes positive. So down here, as x goes to positive infinity or approaches, y approaches positive infinity. But let's look on the left side. It starts to level off and there's an asymptote. Remember dashed lines stand for asymptotes? And as it levels off, it approaches a y value that's neither positive infinity nor negative infinity. It's actually going close to 0. So sometimes your end behavior is at an asymptote, and whatever that y value is, 0, is what it approaches. It'll never reach 0 because asymptotes say that you can't touch that value. You guys understand that? Okay. And then here's another
I'm
end
gonna be honest
behavior.
with
So
you.
let's do this side. As
Miss Shauna,
X, yeah?
I'm gonna be honest with you. I did not hear a word you said because you kind of froze again.
Did I? Well, you know what?
Yeah.
I'm going to upload the video. You'll be able to watch the video, and then at that point, you won't have to worry about it freezing. So you can actually hear this
Only.
piece of it. You can like fast forward and go to it.
Alrighty.
So as X approaches positive infinity, that means the graph is going this way. Where's Y approaching? Where is it going?
Hello.
I hear you. Where's Y going?
What did you say before that?
So as X goes to positive infinity, as we go to the right side of the graph, where do the Y values go on the green graph?
Positive infinity.
Positive infinity. Well done. Okay, so Y is going to positive infinity as X is going to positive. But now look on this side of the graph. As X is going to negative infinity, it levels off. It doesn't go up or down. So what Y value does it approach?
It'd be positive.
Negative?
Nope, it's leveling off. It's neither rising or falling. It's just leveling off straight.
Constant.
It's constant.
What Y value is the question? Does it
Oh.
appear to level off at?
4.
4.
4. Good. So Y approaches 4 as X approaches the negative infinity side of the graph. Okay. And now we're on asymptotes. Okay. So asymptotes are kind of a form of end behavior. So if you look at this graph, they put purple dashed lines through all the places where the graph will approach it but never touch it. So it looks to me like there's a purple line at X is -1, 2, 3, 4, 5. So that's an asymptote. And then there's also one at X is 1, 2, 3, 4, +5. And then this one is a Y value because it's going horizontal. So what is this Y value, do you think? Just count the ticks.
2.
2. Good. All right, so those are the asymptotes, the dashed lines that the graph approaches. So if I said, what is the end behavior of this graph? Well, look what's happening. As X goes to positive infinity, this graph is leveling out at 2. And as X goes to negative infinity, look at what's happening here. This graph levels off to 2 as well. So it's neither going up or down as you go out to the ends. All right, here, read the asymptotes for me here. Read this one first. What do you think this asymptote is? This one is 3. Right here, this one is definitely 3. But what is this one? It's between these two numbers.
1/2.
1.5. Good. So 3/2 are 1.5. So it's right here, between here and here is 1.5. Now, look at this. This graph has also a dashed line here. So what would that be? These two were X's because they go straight up and down. This one is going to be a Y. What are we going to say for that?
3.
Look at your Y-axis. Where's it touching the Y-axis?
0.
0. So because there's an asymptote at y = 0, as you go to positive infinity on the x-axis, your y values are going to 0 because they're straightening out and going flat horizontal right at the 0 value. And then the same thing happens as x goes to negative infinity. Okay? I believe that is it. Okay, so let me show you the formative link. I have to open Go Formative. I'll just talk you through. I'll talk you through what the worksheet looks like because a lot of people were a little confused on it. There is a link in your Google Classroom for this. Under day 2 key features of graphs, there's a formative link, and it'll take you to, I don't want the privacy policy. It'll take you to this worksheet. And here's how you have to work it. There's quite a few different things you do. There's a matching, there's a sorting, there's a multiple choice, there's a select all. So this one says match the graph with the domain. So this is a graph, and you have to figure out which domain it equals. So you can drag it to the proper domain. There's 3 choices here. And if you want this domain, you would have to lock it down here. If you want this one to go up here, you would rise up here. So it'll sort it for you, but you have to connect the correct graph with the correct domain. And then there's another one on range. There's 3 graphs, 1, 2, 3, and there's 3 ranges, 1, 2, 3. And you've got to match the graph with the correct range. So if this one goes down here, you would drag it. If this one goes up here, you would drag it, and so forth. Okay? And then there's one where you have to sort. So what I ask you is this. There's about 6 graphs here. They either have a domain of all reals or a range of all reals. Domain of all reals means they go forever to the left and the right. And range means they go forever up and forever down. So depending on which one it has of all reals, you either sort it here, you can drop it in that box, or if you don't like it there, you can sort it here in the range box. Understood? That's what won't let me, okay. Then for this one, it asks you to write the ordered pair for the x-intercepts and the y-intercepts. And don't forget to put it as a parenthesis, a number, comma, a number, close parentheses. So if they say, what are the x-intercepts? I actually see 2, one here and one here. You need 2 ordered pairs separated by a comma. And for the y-intercept, I see one here. You need the ordered pair in the workspace. The closer you type it exact, the better off you get it right, because if you miss something like a comma, it's going to say you're wrong. Here's another x and y intercept. You have to type as an ordered pair, something, comma, something. And then here they want you to match the graph with the correct interval of increase or decrease. So I gave a piece of the graph from -1 to infinity. One of these graphs increases. You have to tell me which one does that by doing the matching. You grab this little wheel and you drag it to the correct one. And then this one, a lot of people have some problems with. They want to know, how do you evaluate d of -1? Well, we don't have a formula, so we have to read it off the graph, just like you 3 did. If I go to -1 on the x-axis, what is the y value for the point that has an x value of -1? And that will be a multiple choice. You'll select one of these. And this one says, what is f of 1? So again, if I go to 1 on the x-axis, I have to read the graph's y value, and you click it. Okay? And then there's another one there, and another one there. And then I have relative max and mins. So this is, again, another sorting game. So if you think this point is a max, you would drag that point to the max box and let it go. But if you think it's a min, you would drag it to the min box and let it go. All of these have to be sorted into one of these 2 boxes. And then this is your end behavior. Remember, you have 2 ends. You have the left side and the right side. Where do the y values go on the left as x goes to -infinity? And where do the y values go on the right as x goes to +infinity? So this is a select all. If you miss one, you only get it partially correct. There's going to be 2 end behaviors. And this one's really easy. You just read the asymptotes right off the graph. What is that asymptote? What is that asymptote? And what is that asymptote? And so you have to select all. All right. Do you have any questions? That is your worksheet. And I don't need you to upload anything. I just need this to be done. And then there's a quizzes. And I think your code is in. Oh, I didn't give you your code yet. I'll have to give you guys a code right here. So once you're done with the formative, please do the code for quizzes, which I haven't posted yet. Oh, and this is really cool. I don't have any way you can show me your work, so I just put the link there, but I would highly recommend you do this before you do the quizzes. For instance, regarding the graph at the right, what is the x-intercept? Which one of these 4 should I choose?
The 1, 0.
Correct. And then what is the y-intercept?
0, 1.
0, 1. Good. Okay. And it lets you know what you're doing. So I like that it makes you think about that. So I highly recommend doing that little practice link. So you have the formative, the quizzes, and I would recommend the practice. And after I get off with you, I'll upload this video and the notes. So everybody should have everything they need. Are we good?
Yeah.
Good. Then I will see you guys next Tuesday, because this is our last. If you want to see me for office hours tomorrow, you're welcome to stop in for office hours during your time. So if you have any questions whatsoever, you can email me or you can attend office hours. And
Okay.
I will